All right, welcome back. This is what is likely our last summative for the spring of Algebra 2. We are going to cover all this new stuff that we've been doing with trigonometry, and there is nothing old on this test. So our first task in our review is to remember how to graph basic sine and cosine functions. So I have two formulas up at the top here in this box, and I want you to figure out some notes to take down so that can help you through all of this. So which part of this formula represents the midline would be the k value. So you can either tell me it's the k value, that's totally fine, or another way to find midline is to use the calculation. That's not really going to come up in this part of the test. The calculation for midline, where you take 1/2 of max plus min, that's going to come up when we do the modeling on the next section. So the maximum line is going to be your midline, so your k, and then plus the a value. So the a being the size of the wave, so this number in front of the sine or this number in front of the cosine, either one. The minimum line is going to be starting at your midline, but then you're going to subtract the a value. And you really don't need formulas for max and min when you're graphing, because it just becomes kind of intuitive from the graph. How do you calculate the period? Well, that is a formula you're going to need. It is 2 pi, but divided by any b value. I'll use a capital B here. So the number that's inside with the theta, if there's nothing there, there's really a 1 there. Keep that in mind. But if there's something other than a 1, you have to change the period by doing 2 pi divided by b. And then to find the quarter points, remember quarter means to quarter something is divided by 4. So you take the period length, whatever you just got, and divide it by 4. And remember, quarter points are important, because this is what we count by. So sometimes they're fractions, and we'll get over that. What's the general shape? I'm going to ask you this on the test to make sure you know what I'm asking. General shape for a cosine, looks like this, like a U shape almost. And then general shape for a sine is the one that starts in the middle, goes to the top, and then comes eventually back to the middle. Cosine starts at the top and ends at the top. So those are the big differences between the general shapes. And yes, you do have to know that from memory. That's one of your skills. So this guy, they want me to identify a bunch of things first. This is going to help me, as your teacher, grade your progress. So if you can tell me what the size of the amplitude is, then we're in good business. It is the absolute value of this number here. So there's like an invisible 1 right here. 1. The b is the number that I'm going to pull from the formula here. It's sitting in front of the theta, and it's a 4. So because the b value is 4, that means the period, which is 2 pi divided by b, we're going to be able to calculate to be 2 pi divided by 4. Technically, if you left it like this, you're right. However, I would love if you guys could simplify that to pi over 2. Uh-oh, this is going to get challenging. They're going to ask you to quarter point that. So you're going to take the period, which is pi over 2, and you're supposed to divide it by 4. So I'm writing it horizontally because we already have a fraction. Remember, when you divide fractions, you can flip it to a multiplication problem by flipping the second fraction. So instead of 4, because it's like 4 over 1, you could multiply it by 1 over 4. So that means your quarter point is pi over 8. That's what we're going to need to count by. Oh boy, here we go. Midline, I noticed there was nothing off to the side here, so your middle line is still going to be a 0. And then you're supposed to graph, oh boy, it's not going to go very straight for me, a maximum and a minimum line. And they're supposed to be straight, and they're supposed to be evenly spaced. So this maximum line here is a 1, and then down here we have a -1. Make sure you've labeled your axes. And then they do want 2 complete cycles, so you're going to have to count through a bunch of quarter points, so keep that in mind. Starting at 0, that's the first one, and then you're going to count 1, 2, 3, 4, that's 1 cycle, and then 1, 2, 3, 4 more. 1, 2, 3, 4. Just try to make them equally spaced. That'll help you with the graphing. Okay, we need to label this axis though. Remember, we're counting by pi over 8, so this is 1 pi over 8. This could just be left as 2 pi over 8, 3 pi over 8, 4 pi over 8. I know that reduces, but if you want to leave it, go ahead. 5 pi over 8, 6 pi over 8, again that reduces, but just leave it. 7 pi over 8, and 8 pi over 8. So I'm going to notate here because I know some of you are sticklers for this. 2 pi over 8, same thing as pi over 4. 4 pi over 8 is pi over 2. 6 pi over 8 would be 3 pi over 4. And 8 pi over 8 would be pi. If you don't do this reduction that's in red, I'm okay with that. I don't need you to do that. So the last thing we have to decide is where do our points go, and because we have sine, that's the general shape where it starts in the middle, and then it comes back to the middle at the end of it. So at 0, we start in the middle, then we're going to go up to the top, back to the middle, down to the bottom, back to the middle. And then you're going to keep going one more cycle. There we go. So, do the best you can. That was pretty good. Got a little wonky there. Okay, that was pretty good. I'm going to call that a win. Alright, so that's what I'm looking for when I grade this. Can you identify all these things? Can you calculate the period and the quarter point? And then can you go ahead and count forward and label all your axes properly? Please don't forget to label this vertical axes. Usually kids forget that one, even though I know it's really easy. I'm going to let you do this question on your own, but please do check the key to make sure you're doing it all right. And let's look at this one. So this time, the amplitude is still written over here as a 4, so that's cool. The b value, the number inside with the theta, there's a 1 there, which means the period is still going to be a 2 pi, because 2 pi divided by 1 is still 2 pi. And then the quarter point, you're supposed to take the period and quarter it. So for us, that would be 2 pi divided by 4, which I would like you to reduce to pi over 2. So remember, this number here, this is what we're going to count by. The other thing that we have to consider here is your midline is no longer at 0. Your midline is, everything here is shifted down 3. So that's the k value. So your midline is at y equals -3. So I'm okay if you go ahead and call this -3. That's what a lot of kids do. But technically what you're supposed to do is like count down 3 from 0 and say that's your midline. Now, amplitude of 4 would be counting up 4 units. So -3 up 4 units would take you up to here. That's going to be at 1. And then going to your minimum, that would be counting down 4 units. So that's, I'm just going to fudge it in here. That wasn't very even. Alright, so -3 minus 4 is -7. So remember, if you want to use that formula, you did -3 plus 4, which is how you got 1, and then -3 minus 4, which is how we got -7. I really think if you just visualize it, you'll have better luck with that. Now this time I think they asked me just to graph one cycle, thank goodness, because this can get kind of crazy. It's up to you where you put the axes marks. I'm not going to be a stickler about that in Algebra 2. Technically, you're supposed to be marking the axes, which is up here. So this is 0, and then we're going to count by pi over 2. So 1 pi over 2, 2 pi over 2, which, yes, you can reduce that, 3 pi over 2, and 4 pi over 2, which, again, yes, you can reduce that. This is a cosine graph, which means, oops, I crossed off my 4. Which means that you need to start at the maximum line. So here at 0, you need to make a point up the maximum line. And then at pi over 2, you need to come back down to the middle. 2 pi over 2, which is pi, down to the bottom here, back to the middle, and then back to the top. That was so ugly. Okay. It's just getting worse. Okay, so I don't know if I can save this. Yeah, it was just really, really ugly. If I just keep making the points bigger, does it help? So that's what I'm looking for on this question. I need to see label markings on both axes. I need to see the right shape. Good luck. So I'm going to leave that one for you to do. Alright, let's talk about trig modeling. All these formulas I'm having you write down on the review, they're actually going to be given to you on the test. So don't panic like you have to memorize all these. That's not the case. So 2 pi divided by the period is one way to find b value, because remember we need that for the formula. It's also the same thing as 2 pi times the frequency. So those will be given to you. Don't panic about that. The period is 1 over frequency, or 2 pi divided by b. Again, this will be given to you. Frequency is 1 over period, or b divided by 2 pi, in case you need that. All right, amplitude is max minus min divided by 2. And then the k value is max plus min divided by 2. So just so we're all clear, everything that we just wrote down, this is all given to you on the test. Oops, pen, come on. It's going to be like this today, is it, pen? Okay, all given to you on the test. So you're welcome. In fact, I think I literally wrote "you're welcome" on the test. So I really, really, really encourage you guys to start by drawing the picture here. I think it helps tremendously. Keep in mind what you're graphing and where it's being graphed. We're going to graph time along this x-axis, and then your height of your water is along this y-axis. So what's going on here with this water? It varies sinusoidally, which just means we get to graph one of these sine functions. Don't worry about whether it's sine or cosine, guys. It's going to look like this in the test, where I just you fill in the skeleton for me. So one thing we're going to need to find is the amplitude. That's important. We're also going to have to find the b value. And then finally, the third thing you're going to have to find for me is the midline, the k. Most of these can be found straight off the graph. So let's take a look at that. High tide is at 15 feet, and low tide is at 3 feet. So if I want to think about what that looks like, I'm just going to kind of fudge something in here. High tide is 15 feet, and low tide, supposed to be straight, is 3 feet. So we know the max and the midlines, which means we're going to be able to find the amplitude and the midline. So let's start by finding the midline. I feel like that's a good place to start. So this midline here, using the formula for k, which I just gave to you, right? So it's the max plus min divided by 2. So for us, that would be 15 plus 3 divided by 2. So the midline is 9. I'm going to throw that right there in the formula. I'm also going to put it on my picture, because now I should see some really cool symmetry. The amplitude should be the same from the middle to the top or the middle to the bottom. And it is. It's 6 units up and 6 units down. So we're going to put a 6 here for amplitude, but you definitely could have calculated that. Remember, the formula is max minus min divided by 2. So I just like to kind of double check that my picture and my math, everything's working out right. Be careful, guys. If you're typing this in one step on your calculator, you're going to want to put parentheses around the numerator there. But that's 12 divided by 2, which is how we got that 6 algebraically. But yeah, I see it was working great on my picture here. And it says high tide occurred at 6 a.m. And low tide occurred at 6 p.m. So now we have the issue of time, and we're going to measure hours since midnight. So this is midnight. It's called like 0, 100 hours, you know, in the Army. 6 a.m. is 600 hours, but 6 p.m., we're not going to call it 6 p.m. It's like afternoon. It's 6 more hours, so that's 1,800 hours. You got to go Army time, okay? So we're going to have an ending point here at 1,800 hours. There's something going on. Let's see, in the middle, 6. Okay, so you're going to have 6. You're going to have, I can't count, 6, 12, 18, and then we're going to have one more. I got a little crazy here, 24. So this first high tide, this is your quarter point if you want to relay it to something that we just did. Alright, so high tide occurs at 6 a.m. and low tide occurs at 1,800 hours, which means this middle tide, it's not called the middle tide, but is right there, and remember it's sine, so it started on the midline here at 0. So this is what it looks like, and then back at 2,400 hours it would have come back to the middle. Okay? The only thing we haven't figured out yet is B. But if I look very carefully at this picture, guys, I know how long it took to get through one complete cycle. The period is 24 hours. So the b value, remember the formula for b is 2 pi divided by period. So if we do that, that's 2 pi divided by 24. Please leave that as a pretty fraction. That is pi over 12. Oh my goodness, gotta sneak that in. Okay, that says pi over 12. So yeah, that's a complicated question, guys, and the picture is going to help you out and map it out. The good news is this question is kind of the same question all the time. So high tide, low tide, it starts in the middle. The first time they tell you that's high tide, and that's what you continue to count by as you move along, okay? So the next question is about a Ferris wheel. There's a paddle boat, and then there's another high tide, low tide question, and another paddle wheel. So how about I do the Ferris wheel and the paddle boat question, and then we'll call it a day. I'll leave the rest for you to try. So we got a Ferris wheel. It's got a diameter of 62 feet. This is a very important clue when it comes to the picture. It's not going to be part of this, though. So the diameter of the wheel is going to be the difference. It's the range, essentially. So the max to the min is a total range of 62 feet. All right, let's take a look at this. Now the Ferris wheel is not going to start like scraping along the ground. It starts 4 feet above the ground. So I'm just going to kind of sneak in a little line here, and I'm going to call it 4. And then 62 feet above that would be the very, very top. So if you add 62 feet to that, you're at 66 feet. Because remember, the entire range from all the way from top to bottom has to be the entire diameter of the wheel, which is 62. Okay, let's talk about this midline, though. This midline is max plus min divided by 2. So that would be 35. Now this is where I want to trust my picture, but also check that it's working out. 35 to 66 is, what is that, 31 up? And then if I go 31 down, I also get to 4. So there should be symmetry that you see right here along with the amplitude and the midline. Hey guys, we just found the midline. Throw it in the formula. I think we also just kind of found the midline, the amplitude. Remember amplitude, oh, I'm using the wrong color. Amplitude is from middle to top or middle to bottom. And what some kids do for the Ferris wheel question is they realize, oh, it's just going to be half of the Ferris wheel. So you can either calculate it and get the 31, or you could think of it a different way. Now, what is going on here? It says there's one last clue you need to consider, guys. At time of 0, you're going to start at a height of 66. Oh my gosh, that would have been really good to read right at the beginning of my problem. I should have started there. That's why they're making me do a cosine function. Okay? Because if we're starting at the top for time of 0, that's indicative of a cosine. Okay, the last thing we need to find is this b value. Remember, b has a couple of formulas. It's either 2 pi divided by the period, or you could use the formula 2 pi times the frequency. And I think they told us frequency right here, 5 revolutions per minute, which is frequency. So the b value is going to be 2 pi times 5, which is, of course, 10 pi. Throw that in the formula, and we're done. So I get a few kids who are like, you know, Russo, I can figure all this out without actually drawing the picture. I'm just going to do it. If that's you, okay, number one, that's very dangerous because not drawing the picture and just trusting your formulas is very dangerous. Also, if you move on to pre-calc or trig next year, you're going to have much more complicated questions where you're really going to want a picture. But the thing I will ask, if you just give me a formula and you don't have a picture going on, could you please show me your calculations somewhere on your paper? I don't want to be paranoid and think people are cheating, but you know, it happens. And I don't want to catch you in cheating here at the end of the year. Alright, paddle wheel. We have a 33-foot diameter, so kind of like the Ferris wheel, where the diameter of the wheel is going to be the entire range from bottom to top. And then it revolves 18 times per minute. That is frequency. So we'll use, it's very similar to the Ferris wheel question. And then it does say starting at the very top. So let's see what's going on here. There's one more clue. It says assume that it's 3 feet below the water's surface. Well, that makes sense. It's a gigantic boat wheel, like it's not going to be floating above the water. So it's actually going to start down here which I'm going to label at 3 feet below the water, so -3. And then if you go up 33 feet, so -3 plus 33, that'll take you up to 30. So notice the entire range there is 33 from top to bottom. That's the diameter of the wheel. Alright, your paddle wheel though, remember it says it's going to start at the very top. I don't really know if I need to graph much more along, because I don't think I'm going to use the period to find B, I'm going to use the frequency. But one thing I would like you guys to find, whether it's visually or with a formula, is this middle number right here, this K value. So K is max plus min divided by 2. So for us that would be 30 plus -3 divided by 2. I should be able to do that. 27 divided by 2 is 13.5. So that goes right here in the formula. And then the amplitude, this is 13.5. I should write that down on the picture. The amplitude you can find one of two ways. And I suggest you kind of confer with your brain and maybe look at this question a little more carefully than you normally would. 13.5 to 30 versus 13.5 to -3. That is a distance of 16.5 on both ends. 16.5 up and 16.5 down. Well, what some kids do is they take this range and they just cut it in half. So that's the other way to get 16.5. So the amplitude, you could think of it as taking the range and cutting it in half. So that would be 33 divided by 2, which is 16.5. That's going to go right here. Alright, we are almost home free. The B value is the last thing we have to find, and since we have frequency, let's use the 2 pi times the frequency formula. So 2 pi times 18, oops, that's an 18, is 36 pi. So throw that in the formula and walk away. We are done. So nothing worse than having a kid who doesn't try to draw the picture and then makes a really silly concept mistake simply just because they're too stubborn to draw the picture, guys. A picture is going to help you, especially if you're stuck on the question, especially if you're prone to little small mistakes. Please, please, please use your formulas and your pictures on this. This is tough stuff, so I do want you practicing these. There's another high tide question. Here's another paddle wheel question. Alright, moving down. New stuff again. Radian measure. You have to know how to convert radians to degrees. And you are going to have to fill this in on the test, so make sure you know this part. So it's pi radians equals 180 degrees. That's what I'm looking for on this part of the test. And in fact, one of these will be filled out. You just got to fill out the other one, so keep that in mind. So the conversion factor, it's either multiply by pi over 180 or 180 over pi, depending on what you want to do. So like over here, if you're going to multiply by, to cancel out degrees, you're going to have to multiply by pi over 180. And it does say to leave your answer in terms of pi, so they want really pretty answers here. So this is 220 pi over 180, which Algebra 2 teachers would expect you to simplify this further. So keep going. 22 over 18 reduces to, let's see, 11 over 9. So this is, I wrote it over here, I guess, 11 pi over 9. That's your answer for this first one. These three are all the same thing, so I'm just going to do one of each kind. Please, please, please practice typing these in your calculator. This should be a really easy question set for you guys. Everyone should be getting a 5 on this one, so please do so. This next one, though, I have radians and I want to go back to degrees. So this is where you multiply by 180 over pi. And you should see some cancellation before you grab your calculator. Like, for instance, the pi's are going to cancel each other out. They're going to cross-cancel. And then on your calculator, I just need you to type 7 times 180 divided by 2. And, okay, that's 630 degrees, I think. Maybe. So, same idea on all three questions there. Please practice. That should be a really nice score for everyone. Alright, I'm going to give you these formulas. These will be given to you. Except this one right here. There's no formula for this, but you have to know. So this is like the one thing you need to know, that the angle must be in radians. And that's the most common mistake on this test, is they forget that the angle has to be in radians. So, S equals r theta will be given to you. you know that r is the radius of the circle. And then the area formula is 1/2 r squared theta. So these two formulas are given to you, but you must know that the angle is in radians. All right, moving along, we have this clock question, everyone's favorite. We have 11.5 inch long minute hand. That is the radius. And then the minute hand, what does it do during 7 a.m. to 1 p.m.? So the minute hand, every hour, it rotates one full revolution. So 360 degrees each hour. So for this, which is 5 hours, I'd have to multiply that by 360. Oh boy, I don't have a calculator handy. Let me grab one. There we go. Alright, so, whoops, 5 times 360 is 1800. But if I'm calling that theta, we got a big problem because that's not in radians. So then you got to sneak a little pi over 180 thing here. And technically, you are welcome to just keep this as your theta. I know some of you go back and reduce this. So like 1800 divided by 180 is 10, right? Yeah. So you could call that 10 pi if you'd like, if you want to reduce it. But here's the issue. They want to continue on with the question. They want arc length. How far did it travel as arc length? So s equals r theta, which means s equals 11.5. And then times that theta, which is this guy right here. I'll just write it as 10 pi, so that way I don't have too much to write anymore. Alright, so 10 pi. Decimal answers, please. I love decimal answers on these questions. This comes out to 500, nope, no it doesn't. 361.3 inches. Alright, and then this last question I love. You know, it's an area question. They give you the formula right here in the question. His chain is 25 feet long, so you can run out 25 feet. That's the radius. And the angle that he can rotate is 120 degrees. So that's kind of the problem right there. You can't call theta 120 degrees. In this formula, and the other one, theta has to be in radians. So 1/2 times the radius here is 25. So times 25, make sure you square that radius. And then for the angle, this theta thing, you can start with 120, but then you're going to have to remember to multiply it by pi over 180. So that way it gets converted to radians. So when you type this in your calculator, I don't know what it is. Can't do that in my head. All right, 0.5 times 25 squared times... Alright, 654.5, and a label on this would be feet squared because it's area. Okay, so I think that's the end of your test, and that's our last little summative. We got some post-tests and finals coming up, but good luck to everybody. Hopefully you get some good scores, and then we don't have to worry about retakes, because frankly, we are out of time.